another triangle, and the question asked me, in a scalene triangle, the smallest is 2/3 the size of the middle angle, and the middle angle is 3/7 the size of the largest angle. Find the measure of all three angles. Okay, so scalene triangle, I know that all three angles have to be of different length. Okay, so I just drew out a diagram to maybe help myself, but I know that A plus B plus C in a triangle all have to add up to 180, and I'm basically being told, right, so that A is greater than B and B is greater than C. Okay, so if I read that there, so I was told, okay, in the question, that the smallest angle is 2/3 the size of the middle angle, okay, and then the middle angle is 3/7 the size of the largest angle. Okay, so I'm just going to work through this here. Okay, so I'm going to say this is 2/3, so C is 2/3 of B, and I'm going to say B is 3/7 of A, and then I'm going to say that C then, okay, is 2/3, and if I know that B is 3/7A, okay, so C, B, so C has to be equal to C times B here. I'm just replacing it here. So I get 2 by 3 gives me 6, and 3 by 7 gives me 21A. Okay, so A is greater than B is greater than C. So I know that C is 2/3 of my smallest angle, and then B is 3/7 of my largest angle, and then C then has to be equal, okay, so 2/3 times 3/7 A, which gives me 6/21A. What I have then is I know that A, one of my angles, plus this is my B, 3/7A, and this is my C. Okay, so we have all the same term being used, and that's equal to 180, because we know three angles have to add up to 180. So I'm after making a common denominator, which is 21. Okay, so this would be over 1. Okay, so 1 goes into 21 times A, plus 7 goes into 21 3 times my numerator, which is 3A, and then 21 goes into 21 once, times my numerator, which is 6A, and that's equal to 1 goes into 21 times 180. So I get 21A plus 9A plus 6A is equal to 3,780. So I get 36A is equal to 3,780. So I get A on its own, I divide across by 36, and I get A is equal to 105 degrees. Okay, and then I'm going back subbing in. Okay, so I basically know that A is my largest one. Okay, and I know now, okay, so B was 3/7 A. Okay, so I go 3/7 times A, and that's equal to 45. That's what B is. And then C is my smallest angle, so I go 6/21 times A, and I get 30 degrees. And that's that question fully completed. The next question was question 7. Okay, so question 7, we were asked about a trapezium here. So question 7 says E is the midpoint of DC. Okay, so this is my midpoint here. Draw the image of the trapezium ABCD rotated by 180 about the point E. Okay, so 180, it's doing a half turn. Okay, so this is what it's basically going to look like. It's just doing a flip, a half turn. Okay. And then we have what shape is being made by the image and the original trapezium. So the shape that's being made now is a parallelogram. Okay, and then what is the area? What is the area of this composite shape? Okay, so the area of parallelogram is A plus B H, okay, so two lengths of the parallel sides times perpendicular height. So it's going to be AD plus BC times my perpendicular height, and then a trapezium then is half the area of the parallelogram. Okay, so it's half of it. Okay, so half A plus B H, so it's going to be A plus B over 2H, and that's my formula for the area of a trapezium. So that's after proving it there for part 3. Question 8 says 3 times the width of a certain rectangle exceeds its length by 3 centimeters, and 4 times the length is 12 centimeters more than its perimeter. Okay, find the dimension of this rectangle. Right, so I wrote out a rectangle. Okay, so we know in a rectangle opposite sides are equal, so I had to use 2 different unknowns. So I said x was equal to my width and y was equal to my length. Okay, so in this question it says 3 times the width. Okay, so if I said x is my width, so I'm going to say 3 times my width would be 3x, exceeds twice its length by 3 centimeters. So exceeds means it passed it. So I'm going to say is equal to twice its length, so 2y, and then passes it by 3 centimeters. So I'll say plus 3. Okay, so that's one of my equations there. And then I also have and 4 times its length. Okay, so 4 times its length is in y. So I'll say 4y is equal to its length is 12 centimeters more than its perimeter. Okay, so I'll say 4y is equal to twice. Okay, so its perimeter is going to be twice x plus y. Okay, so twice its perimeter, so 2 times x plus y, and then it exceeds it by 12 centimeters as well, so I'd say plus 12. And then I multiply this outside. 4y is equal to 2x plus 2y plus 12. So I have 4y, bring over my minus 2x minus 2y minus 12 is equal to 0. So I have minus 2x, alright, so I'm just minus 2x, 4 take away 2 is plus 2, minus 12. That's one equation, and I have equation up here as well. So I have 3x minus 2y, bring over the 2, and then I bring over my plus 3 becomes minus 3 is equal to 0. I have a simultaneous equation here, and I'm able to solve for my unknowns. So here I have plus and minus, so I can just cancel those off, they're already eliminated. So I have minus 2x plus 3x gives me x, and I have minus 12 minus 3 gives me minus 15. So I have x is equal to 15. Then what I have is I have 3x minus 2y minus 3 is equal to 0. Okay, so I'm after figuring out what x was, so I'll go 3 times 15 minus 2y minus 3 is equal to 0. So I have 45 minus 2y minus 3 is equal to 0. Minus 2y is plus 42 is equal to 0. So I'm going to have 2y is equal to 42. Y is equal to 42 divided by 2. So y is equal to 21. Okay, so that's what the dimensions of my rectangle had to be. So it's just really important that you read the questions really carefully, and you look at the information that they're actually after being given you. Okay, so as you can see, there kind of are patterns going through these questions. So that's question 8. The next one then was about Peter. Okay, so Peter has 3 narrow arrows of length P, Q and R, where P is greater than Q and that's greater than R. Okay, right, so if it helps you, you might want to consider using numbers to maybe give an example of it, so that you'd actually be able to phrase it. You'll be able to find out different information. Okay, so what it says, he wants to make a trapezium shape with 2 right angles as shown. Okay, so in the book you have the 2 right angles, so we need to make a trapezium with that. The dotted line completes the trapezium. Okay, so then we have to draw 3 possible arrangements of rods, and given the inequality above, find the arrangement which has the greatest area. Okay, so I'm told if A is greater than B, then AC has to be greater than BC, and given that C has to be greater than 0. Okay, right, so what I have here, okay, is first of all I just put R here, I put P along here, and I put Q here. Okay, so that's my first arrangement that I did, and I'm just going to call this area 1. Okay, right, so area of trapezium is my 2 parallel sides over 2 by my height. Okay, right, so I have P plus Q over 2 by my R. Okay, so it's P times R gives me PR, Q times R gives me QR, and that's all over 2. Okay, so that's the area of area 1. Right, another way I could have done it is I could put, I'm just rotating them around now. Okay, so I'm going to put P in the top, R at the bottom, Q at the side. So I could have my area then is this another trapezium, so I'll have my 2 parallel sides, so P plus R over 2 times my perpendicular height, which is Q. Going to multiply them out, so I'll have P times Q gives me PQ, R times Q gives me RQ, and that's all over 2. Okay, so that's my area 2. Then I have the third way that I can draw this shape is I can do it by having P along the side, Q at the top, and R at the bottom. Okay, so I'm going to have my area then is my 2 parallel sides, so it's going to be Q plus R over 2, and then times my perpendicular height, which is P. So then I'll have Q times P will give me QP, R times P will give me PR, or RP, all over 2. Okay, right, a fact that I know, okay, that P, okay, is greater, it was given to me in the question, I was told the P was greater than Q was greater than R. Okay, so now I'm saying that PP is going to be greater than PQ, and that's going to be greater than PR, because we know that P is greater than Q is greater than R, okay? So then if that's the case, PP would have to be greater than PQ, and it would have to be greater than PR. PQ is going to have to be greater than PR as well, okay? So you're just looking at the letters involved, okay? So that implies, okay, that PQ is greater than PR, okay? So that's what I've just stated there. Okay, right, so the first thing I'm actually going to do is I'm just going to compare area 1 and area 2, okay? So area 1 we've got is PR plus PQ over 2, and area 2 I have PQ plus RQ over 2, right? But I know since PQ is greater than PR, okay, so PQ, right, so I have PR here, I have QR here, I have PQ here, I have QR here, right? But I know that PQ is greater than PR, okay, so this is going to be greater than this here, and then that means that area 2 has to be greater than area 1, okay? Right, so I know that area 2 is bigger than area 1, so now I'm going to go off and compare area 3 and area 2. So area 3 is PQ plus PR over 2, and area 2 is PQ plus QR over 2. I know that P is bigger than Q, okay? Right, so I'm going to be able to say that area 3, so P is going to be bigger than Q, so I'm going to be actually able to say that area 3 is bigger than area 2. So then I'm going to say that area 3 is greater than area 2 is greater than area 1. And if you actually even looked at your diagrams, girls, you would have been able to spot that off straight away by looking at the diagram. Okay, and now we have question 10. So question 10 says, using the measurements given, find the area of this trapezium, and it just says diagram not to scale. Okay, so here I have the trapezium, and I need to find the area of this trapezium. Okay, so I'm just after making it into a rectangle more so, because I was told that the diagram isn't to scale. So I look at here, and I have, okay, so this is 5, this is 5, and then I'm just going up along the sides, up along over, up along the sides, up and over, and I have basically, I don't have my perpendicular height, okay, so that's what I need to find, okay, so that's why I'm after making my rectangle. And so I know that the full length over from here to here is 14, so that means the full length from here to here has to also be 14, and this is 6, so I am missing 8, okay, so I'm just going to have 4 to this side, 4 to this side, and then now I have a right angle triangle, and this is going to help me find my perpendicular height, okay. What I have then is I have 4 and 5, so I have a squared plus b squared is equal to c squared, so I'm going to have my 4 to be squared plus my b to be squared is equal to 5 to be squared. So I have 16 plus b squared is equal to 25, b squared is equal to 25, bring the 16 over, it becomes minus 16. So I have b squared is equal to 9, so I get b is equal to 3. So b is my perpendicular height, so from here to here that's 3. So now I can find my area of my trapezium, no problem. So I go my area of my two parallel lengths, so 6 plus 14 over 2 times my perpendicular height, which is 3, and the area of that shape is 30 centimetres squared. So that was question 10. The next one then was question 11. So question 11, it says the area of an equilateral triangle is 173 centimetres squared. Find the length of one side. And then it asks me the length of one side in an equilateral triangle is 10.75 centimetres. Find the perpendicular height of the triangle, and hence find the area of the triangle. Verify your answer using the triangle formula, a is half AB sine C. Okay, right, so the first thing I need to do is the area, find the length of one side. Okay, equilateral triangle, all three sides are going to have to be the same. Okay, so the area of a triangle is equal to half by base by perpendicular height. Okay, right, I'm just going to call each of my sides 2A, 2A, 2A. Okay, the reason why I call it 2A is it just it avoids me having to have an A over 2. Okay, so half, and so I'm just going to have a nice number A. Right, so what I have then, so my area is half by base by perpendicular height. I'm after creating a diagram here, so this is my equilateral triangle, each side is just 2A. I want to find my perpendicular height because that's what I need for my formula. I have my base, but I don't have my perpendicular height. So what I have here, I draw a line up and I'm going to split my triangle in two. So this is going to be A, this is 2A, and I'm going to work out what this is here. So I've drawn out the diagram like so. So this is Pythagoras' theorem is going to come into play here. So I have A squared plus B squared is equal to C squared. Okay, so this is my right angle. So the side opposite the right angle is C squared. So I have A squared plus my B to be squared is H squared, and that's equal to C squared is 2A to be squared. So I have A squared plus H squared is equal to 4A squared. So I have 4A squared is equal to A squared plus H squared. I just moved things around. Then I have 4A squared minus A squared. So I'm going to bring over my A squared, and that's equal to H squared. So I'll have 3A squared is equal to H squared. So I'm going to get square root both sides. So I'll get root 3A is equal to H. So now I have my height. Okay, so I have my base and I have my height, right? So I'll go, the area is equal to the half by the base by the height. So half by my base of my triangle is 2A. By my height is root 3A, and that is equal to 173 centimeters squared. Okay, I'm looking for A, my length, okay, and that's the only variable that I have left now, okay. So I have a half by 2A will just give me A, and multiply that by root 3A, right? So then I'll have A by A gives me A squared, so I'm going to have root 3A squared, and that's equal to 173 centimeters. So what now I have is A squared is equal to 173 divided by root 3. So I get A is equal to the square root of 173 over the square root of over square root of 3. And I put that straight into my calculator and I get 9.994. Okay, so 2A is equal to, sorry, that should be 19. 19.994, right? I want to get, oh no, sorry. Oh, my base was 2A, sorry, that's why. My base was 2A, so I need to find 2A, so my base is 19.99 centimeters. Part 2 of this question then, it said the length of one side in equilateral was 10.75 centimeters, right? If my length was 10.75 centimeters in an equilateral triangle, all three sides have to be the exact same, okay? So then what I need to do is I need to find the perpendicular height of the triangle and hence find the area of the triangle, okay? So here is what my triangle would look like. So if one side is 10.75, okay, I draw out my triangle again. I need to find my perpendicular height. So I split my triangle in two to make my right angle triangle. And 10.75 divided by 2 gives me 5.375. Okay, and then I'm going to do my A squared plus B squared is equal to C squared. So H to be squared is equal to 10.75 to be squared minus 5.375 to be squared. Okay, I've just rejigged the formula around a little bit. Okay, so you can, the step that I would have done before that, if you want to just double check in case I've lost you, it is A squared plus B squared is equal to C squared, right? This side is going to be my C squared, okay? So I'll have H to be squared plus 5.375 to be squared is equal to C squared is 10.75 to be squared, okay? So that's why it's H squared is equal to 10.75 to be squared minus 5.375 to be squared, okay? So I get H squared is equal to 115.5625 minus 28.890625. So I have H squared is equal to 86.671875, and I get H is equal to the square root of that. So my height, my perpendicular height here is 9.31. Okay, right, but that's not all that I was asked. I'm asked to find the area of my shape. Okay, so the area of a triangle is equal to the half the base by the perpendicular height. Okay, so it's half my base here, or any side of it, is 10.75, and my perpendicular height we just found out was 9.31. Okay, so my answer then has to be 50.04 meters squared. Right, the second part of this question is that they wanted us to find it out using half AB sine C. Right, we have an equilateral triangle, so that means that the angles in the triangle have to add up to be 60 degrees. Okay, so I have half AB sine C, right? All my three sides are equal, so all my sides will have to be 10.75. So I have the area is equal to half 10.75 times 10.75 sine 60. right? And when I put that straight into my calculator, I get the area is equal to 50.04 centimeters squared, and that's exactly what I found out for the first part of this question also. Okay, so then for question 12, I'm dealing with this shape here. So it says find the area of this figure in square meters, correct 3 decimal places. Okay, so we know here, right, this is a rectangle, but there's a triangle after being cutting out. But these lines are telling me that they're all the same length. Okay, right, so if this here is 8.4, up here it has to also be 8.4. Okay, so the first thing I'm going to do is I'm going to get the area of my rectangle. So the area of a rectangle is 5 multiplied by 8.4, okay, so length by breadth, so it's 42 meters squared. Right, so my area of my triangle is half by base by perpendicular height. But I don't know what my perpendicular height is just yet, and I'm not sure if I have enough information to do it. So what I need to do is I need to start looking, and I have to go, first things first, I have to go 8.4 was one side of my rectangle, okay, and those 3 lines were trying to tell me that they are divided into 3 equal segments, okay, so all those lines have to be the exact same length. So I go 8.4 divided by 3, and that gives me 2.8. Right, the 3 lines in my triangle also is trying to tell me that's actually an equilateral triangle, and that the sides are all 2.8. I don't have the perpendicular height, and I don't have enough information to go off and find my perpendicular height. Well, I could go off and divide my 2.8 and so on to get my angle, but it's easier to just use my formula half AB sine C. Okay, so what I have here is I have half my base here, my 2 sides, okay, so 2.8, 2.8, because all 3 sides have to be the exact same, and in an equilateral triangle the angle has to be 60 degrees, so I go sine 60, so I get that area of that triangle is 3.3948, okay, right, so the area of the shape is going to be 38.605 meters, and the reason why was because my area of my rectangle altogether was 42, and I take out my little triangle that was after being formed, and I get 38.605 meters to be squared. Question 13 then. Question 13, it is a regular hexagon is circumscribed by a circle of radius 5 centimeters. Okay, so that's telling me, guys, that all those lengths in that circle is 5 centimeters. Okay, so I need to find the size of angle EOD, the size of angle ODE, and the area of the hexagon. Okay, so if I wasn't sure what a hexagon is, I just count up the number of triangles. There's 6 different triangles in that shape, so I need to find the area of all of those 6 triangles. Okay, but the first thing I do, I say that angle EOD is equal to 360 divided by 6, so it's equal to 60 degrees. And I can also say that the distance from ODE is equal to the angle ODE is equal to the angle OED, okay, because they have equal radiuses. Okay, so that's what they were trying to tell us. Okay, so they're all 5 centimeters each. Okay, so then I can say that angle ODE plus angle OED is equal to 120. So ODE is equal to 60 degrees. Okay, the area then in part 3 of this, I need to get the area of one of my triangles. Okay, so I'm going to use half AB sine C, or sine theta. Okay, so I have half, right, all my sides have to be 5 centimeters because they're all radiuses, so I say half 5 by 5, and my angle in an equilateral triangle will have to be 60 degrees, so my area of that particular shape is 10.825 centimeters squared. Okay, so that's the area of one particular triangle, but I have 6 different triangles in my shape. Okay, so I say 6 times my area, so I go 6 by 10.825, and I get the area of that full hexagon is 64.95 centimeters squared. Okay, so now I'm on to question 14. So for question 14, it says the complex design of a regular polygon is shown. Find the size of the angles alpha, beta and theta. So if the square has size of 4 centimeters, find the area of this composite shape correct to the 1 decimal place. Right, so what I need to do is I have, first of all, okay, so I have a pentagon, and I have base angles, okay, so I have here, it's divided into 8 equal pieces, okay, so this is the pentagon, so I have 1, 2, 3, 4, 5, 6, 7, 8 sides, so that's why I know it's a pentagon, okay. So full rotation around this would be 360 degrees. So I go 360 divided by 8 will give me 45. So this angle here has to be 45, okay. But I know in this shape that they're all isosceles triangles, okay, they're all congruent, so my base angles have to be the same, okay. Right, so I go 180 take away 45 divide by 2, and that gives me 67.5, okay. So this angle here is 67.5. Right, I'm looking here for this particular angle, alpha, right. So I'll say alpha is equal to, right, so full rotation, okay. Right, so it's a full rotation, so what I have is 360 take away my 90 degrees from my square, the right angle, okay, take away 2 of my angles because I'm going to have another one here, 67.5, so that's why I take away 2 of them, and I'm left with this particular angle is 135 degrees. So I have this one in, I have this one in, and okay, so that's how I found that out, that particular angle. The next part then is I have a hexagon, okay, so the internal angle, okay, so I go hexagon, the internal angle, we know full rotation is 360 degrees, there's 6 sides in a hexagon, so I go 360 divided by 6, and that gives me 6. And once again, all of those triangles that are made in the hexagon are congruent, so the base angles are the same. So I go 180, take away 60, and I divide that by 2, and I get they're equal to 60 degrees. Okay, right, so then what I need to do to get my theta, okay, so that's basically going to be 2 base angles, so it's 2 by 60, so that gives me 120 degrees. Right, the next one that I'm trying to find is beta, so that's down there, the square, okay, so I go, it's the square, which is 90 degrees, and I'm also dealing with my, the angles that are going to be affected is my hexagon, okay, so I'll have 360 minus 90 minus 2 of my angles there, okay, so if you look at the diagram that I've drawn out, you'll be able to make up your own little, so you'll see why I've done 2 times 60, and that gives me 150 degrees. The next part of this, then it says it wants me to find the particular shape. I know that sides of the square are 4 centimeters. Okay, so we know that if there's 4 centimeters in square, all those 4 sides are the same. Okay, so I get the area of the square is equal to 4 by 4, and that's 16 centimeters squared. Then I have the hexagon, okay, so the hexagon is made up of 6 different small triangles, okay. Right, so I get the area of a triangle by using my formula half AB sine C, okay, so sine my theta this time, okay, so my area of my hexagon is 6 times half. Okay, so if one of those sides is 4, that means that the other side has to also be 4 in my hexagon, because all the 6 sides in a hexagon are also equal. Okay, so it's half 4 by 4 sine 60. We already had that angle, so we get the area of the hexagon is actually 24 root 3. Right, now I need to find the area of a hexagon, or pentagon, okay. Right, so what I have here, okay, so I have that this length here is into 4, okay, but I don't have my height, and also the base here, we're dividing this part up into 8 different sections, okay, so what I need to do is I need to actually find out what my perpendicular height is, okay, and when I work it out, you'll even be able to look back at a previous example because it's very similar, we use the same figures, okay, so the full length is 4, this split it up, this will be my h. We already know what my angle is in here, okay, so it's 67.5, we found that out, okay, so I'm just going to have h is equal to 2 tan 67.5, so I get my area is equal to 8 times half by 4 2 tan 67.5, and I get then 77.25, and my total area then is 134.8 centimeters squared. I added up all my figures, so I added up my square, my hexagon and my pentagon to find that full shape. Question 15 is next, okay, so for question 15 I was given a drawing of the cross section of a skip is shown. So the skip company wants to draw a line along the side of the skip indicating half full, okay? So by forming simultaneous equations using the dimensions given, find the length of the line x and the height of y in terms, height of y in the base. Okay, right. So what I have here, okay, so I looked at the area of the top, okay, right, so we have a trapezium here, okay, so it's my two parallel lines, so it's going to be x plus 10 over 2y, so I'm getting this area here, okay, so it's x plus 10 over time, particular height in this particular one is y, okay, and then the area of the bottom is going to be 20 plus x over 2, and then my perpendicular height is going to be 8, take away this y, okay, so from here, so if the whole way is down is 8, then here is just going to be 8 take away y, right, so my total area then is going to be equal to 20 plus 10 over 2, 8, and it's equal to 120, so that's my total area of the shape. So I did 20 plus 10 over 2 times my perpendicular height is 8, and that's 120 centimeters squared. Right, so that means we're looking at half full, so we can say that x plus 10 over 2 y is equal to 60, because half of that to be full would be 60. Right, so then I multiply this out, so I go x times y will give me xy, 10 times y will give me 10y, and I've got rid of my 2 by multiplying it across, and that's equal to 120. So I have xy is equal to 120 take away 10y. So I have x is equal to 120 take away 10y all over y. And then what I have for b, okay, so the second one, I have 20 plus x over 2, but 8 minus y is equal to 60, because that's the other half of it. So I multiply this out, and I get 120 y plus y minus xy is equal to 120. I multiply that across by 2. Okay, so then I have 160 minus 20y plus 8. I'm filling in for x, so I just worked out that x was 120 minus 10y over y. So I fill in for x, okay, and then I tidy up all my multiplying, and I have minus 20y squared plus 960 minus 80y minus 120y plus 10y squared, and that is equal to minus 40y, okay. And then what I have is I have y squared plus 16y minus 96 equals 0. I have a quadratic here now that I need to solve, so I use my minus b form to solve it, and when I solve it I find out, okay, that y is equal to 4.65. I sub back in to find my x, and I get x is equal to 15.8 centimeters.